Okay, finally, there we go. We are live. And we got Restream being completely stupid this morning. No drop frames, finally. Restream is still being super weird though. None of my windows are working. They definitely had some sort of weird outage. Oh well, I'll just pull up the YouTube chat. And then I'll just get to work, I suppose. It's like incredibly obnoxious to me when I'm just trying to start my work and then my default service just like randomly decides to not work and I have to spend an extra 15 minutes futzing with it. There we are. It says live. So we'll see whether I actually see stuff in chat or not. Whatever. Take this off. Okay, cool. So what we're gonna do now today, we have a whole day of work to do. I want to get Puffer into a actually like somewhat respectable state today. Okay. And we're going to use Claude for some of this, but the goal is to not overuse it today because, a lot of the mess we're cleaning up is Claude slop mess. I also got the new Puffer mug. We get the Puffer fish mug. Hey, Liberty. It looks like my chat is working correctly, so that's nice at least. Here, I can move this preview to be bigger. There. Now at least I can see the chat properly. Here. Stick something on the background, and then I'll go through what we're gonna do. Okay. So here's what we have to look at today. 2,000 lines worth of this crap. Yeah? 2,000 lines worth of this crap, dang. Yeah, I think I'm going to use Super Maven a lot more than Claude today. We'll keep it lightweight. Oh, this is a little sketchy, isn't it? Well, wait. Is there a copy and cast in one op? We can just use Claude. No, this is very stupid. This is wrong. Yeah. We have to leave it the way it is. It's annoying. It's like so verbose. This. Well, I think there are several things we can do here. Let's go get our like our main logging stuff done first. Way too much. Yeah. Don't do that, man. It's bad. But the thing is, it's just wrong. Like, this is not... It's like, oh, a single kernel for copy plus cast. Motherfucker, a copy is not a kernel. Like, what are you doing? Hey, Quinn. Alright, so let's see what we want this to look like, because we have this this sort of profiling shenanigans going on here. I kind of want to co-design this a little bit with... Let me check the profile. Okay, so... Ooh. Can I just, like... What you're doing today, we're gonna try to clean up everything a lot, so we can actually have this be, like, usable and maybe have a pre-alpha. Wait, this doesn't make sense, does it? How does this make sense, what we're doing here? Make sure I didn't screw this up. So pretty much, like, there's some tags that have to be in here, right? And if I can, I want to make it in a way such that it's useful for both the main run code and the profiler. I hope I'm not getting sick. I feel a little funky today. Be super annoying. I literally do not go anywhere other than here in the gym. And yesterday I went to the gym, I ran 10 miles, and I left. We'll go with kernels here. That should be enough to test. TinyGrad, good or bad, support the idea. So I like a lot of what they've tried to do. It kicks the hell out of Jax, for sure. There's some stuff I don't like. I really, really wish that their stuff were written in C, or like C with a Python bind instead of it being pure Python, for sure. Their kernel gen is not fast enough and is too abstracted right now, so that it's difficult to actually like get human readable kernels and edit them and stuff. But I think overall what they're doing is fantastic, and I'm really a big fan of like the software quality and a lot of their stuff that they have is just way, way higher. Um, Unfortunately, Python is still cancer. It's just like it's an irredeemable programming language. Lack of specific data structure for RL. Mix of vector and wait, lack of specific. I don't know what that means, dude. Database that will be a mixture. I don't like that doesn't make sense. Oh, come on. No CUDA GPUs? Alright. Because you don't run it with MSys, right? Vibe coded a TinyGrad clone. Well, like, you can't just say, "Oh, I vibe coded a TinyGrad clone." Like, do you have numbers and stuff, right? Because the number of people who've told me, "Oh, I just vibe coded up a thing," and they've been wrong, and like it's actually been crap, is very large. So I don't really necessarily care how you did it. Is if you have something that you actually think is good, though, and you have numbers to back it and test, then I will look at it. I'm just generally suspicious because I have access to the same tools that you do, and I know that they're not as good as people say they are, and I know that that type of a thing is outside of the range of its capabilities to do well, right? Hmm. I was training my RL library, GitHub. Go on, link it then. I'll take a quick look. 400 contributors and tens of thousands. Well, I mean, look, that's not all. That's also not a good signal, right? Because Torch has like Torch is gigantic and Torch is garbage. It's just the least bad thing that we have. But like TinyGrad, when I look at TinyGrad, I can actually see like chunks of it were made by like I can see chunks of the design say, "Oh yeah, that was made by somebody who knows what they're doing and gives a fuck." Right? That's the difference. So like a lot of TinyGrad, they just need to fix perf. Like a lot of TinyGrad is perf optimization. It's kind of like a bad implementation of a good design, which that is no um that's no disrespect to them, right? It's new. Of course, it's going to be a bad implementation. But the fact that they've gotten the design good this early is pretty interesting. Tiny fin. Okay, let me look. Let me look at this. I'll take a quick look for you. Tiny fin is funny. Okay, so literally the very first thing that you should have in here, Liberty, is if you're gonna have this, the very first thing you should have is like perf metrics, right? This is a symlink. Heck. 2000 SPS. You don't need CUDA for 2000 SPS though. You can get 200,000 SPS on a CPU. So like, what am I supposed to do, right? And it looks like the element wise, these are being done on CPU as well. Yeah. I mean, you've seen me like doing this type of stuff on stream, right? Like you've literally been watching me using to some extent quite heavily in places LLM tools, but like you need you need obviously correctness tests. I think you have those. You need perf checks. You need some sense of how fast you think that the op should actually run, right? Like look at this, right? I have these. And I have timings versus torch for the same ops, right? I have coup de grace timings. So I don't want to discourage you, right? I do. I actually, what I'd like you to do is, like, I'd like to encourage you to learn more stuff with it, right? You can keep using your same tools, but dig a bit deeper into it. You know, write some high perf stuff. Hey Jess, we're fixing up a lot of stuff in Puffer today. Okay, so this does not contain. That is weird. What the heck are they doing with this? Are those implemented in C or Python? So my stuff, I have a variety of things, right? I have kernels in CUDA. I have C++ torch bindings. I have tests that are C++ slash CUDA. The test could just as easily be Python. I actually think it's not really any easier to do it in Python, so I just have them um, in C++ and CUDA. Um, like I have several things. It's all in 4.0 if you look at some of the recent stuff. And for reference, just to prove to you that this is completely doable, I did not know this stuff. I'm gonna say 6 months ago. I had written one kernel ever before I started Puffer 4.0. But I'm putting the effort into like actually understand this stuff, and I'm not just outsourcing it all to Claude, right? You need to be a little bit more disciplined, I would say, with how you use the tools. You definitely don't want to use it in place of learning something. You should use it in place of like having to deal with a bunch of boilerplate crap that doesn't actually mean anything and mostly just waste your time. You'll get to see, if you're watching today, you'll see a lot of this stuff that I'll be working on. I have a ton of stuff that I want to get done with this today. Interview at OpenAI, congrats, man. I have no idea how it is anymore, but when I was there, when it was a much smaller company, I've been very public in saying it's the best place I've ever worked. I've been critical of a lot of the stuff they do nowadays, but that much is still true. Why is this like this? I think I just did this in the wrong layer, right? Can these get queued parallel? I think these can get queued parallel, can't they? Did I screw this up? Push for real RL. Yeah. Honestly, just we don't need I don't need the backing of one of the bigger companies to do this anymore. It's just fine. Like everything's gonna be working in a year or two. We don't need additional investment to do it at this point. Kind of cool. Same stream is serialized. Okay. Okay, that's fine. Events are stream ordered. Regardless of when the CPU moved on. Okay, so this is fine. But then I can't do these NVTX tags, right? Why did I have these anyways? I just forgot what I did pretty much. Introducing ads. So the way that they're doing it looks to be reasonable for now. We'll see whether it remains reasonable going forward. As soon as companies start putting ads into the actual LLM output though, or having the LLM itself advertise stuff to you rather than just putting it on the side, like, no, burn it with fire. Oh, hey Sam. Seen Dev Channel? I have not. I had an important meeting yesterday and then I crashed for a bunch of hours. What do we got? I have been messing with your drone code for something though. Oh, Sam, can you answer something real quick for me? There is no, I can't get the current drone env to render. Like, there's this include render. Like, the render file doesn't seem to be included. What am I looking at in dev? Oh, holy shit. Let's see. Wait, why doesn't it play? Ah, stupid Discord. Hang on. Hang on. Discord, damn it. Give me my movie. No, it's a dot move. Great. I can't play it. Shit. Hang on. Don't you dare try to make me make an account, stupid FFmpeg wrapper. I don't think you're live on X. If I'm not live on X, it's because Restream is broken, man. Pushing out, maybe you win 1 million. What do you mean you win 1 million? Then it crashed. Yeah, so unfortunately everything is super jank today. Like Restream is a mess. Do I not have literally any video? I don't have a video viewer on this machine. Alright, 1 second. I love how with Linux, I love that Linux, that's how you get a video player. In 5 seconds. Okay. Yo! Das is a drone. Holy. Wait. This is the RL agent, right? Just trying to hover? And then what's it doing? What am I looking at? And also I'll tweet real quick that I'm live on YouTube all day. RL halfway through. Let's see what. Fully onboard model, direct motor control, 100 lines of firmware. Dude, this is sweet. Taking off, and then we swap using the RL controller. Okay, awesome. That's sweet. Lighting in the hallway hovered for 5+ seconds. The lighting in the hallway. Oh, what's the wait, what's it need lighting for? Like what sensors does this thing have? Oh, it probably has like a depth sensor or something? Yeah, no, the OpenAI ads aren't bad, Jackson. I'm not gonna just blindly hate on everything that they do. If they keep it that way, it's fine. It gets a bit wobbly as the RL. Top article in the next 2 weeks. Yeah, there's no way like a niche RL article is gonna do that. Opflow. Okay. Well, that's freaking awesome. Yo, Finn, does the current one work? Does the current like drone env work in Puffer 4? Because I remember I merged some PRs and I started trying to use it for something. Prompted. Haven't tested it. Well, no, it doesn't need to train on 4.0, but like there were some env changes. It should be fine otherwise. Okay. So like, because there were some env changes, and like I went to do this here. I think this will still work. So I don't know, is there like was this a bad merge or something? Because it doesn't have the render bindings. Try an unstable training run. No, Jess, it might be by the end of today if you're lucky. Yeah. If you could just figure that like thing, thanks. That would help. I don't know, I just have an env I'm working on that like is uses a minimalized version of this, and I was confused if I broke training or if training was already broken or what. Drone PR to 4. Since you already have it in 4, you can leave it in 4 and go back to 4. Yeah. All right, thank you. Nice progress. Very, very solid. Okay, this is what I was doing, right? Yeah, this. So, okay, so my NVTX regions aren't really doing anything like this. What would need to be done to fix refactor auto tune? Oh, auto tune is going to be. So the problem with auto tune, Jess, it was meant for like the old CPU ends. Like the whole VEC is going to be different. We may or may not even need it in the new version. We'll see. Yeah, okay, so we just don't need this then. I think we just don't need this at all. So, okay, that's useful. Okay, so this will be better for the profiler. Next PR should be 3. Is it... No, I thought, didn't you already PR the drone to Puffer 4, or is it in 3? It should be to wherever you already have the drone. I thought you did it to 4. Is this not the latest one here? This is the one where you guys merged everything, right? So that you have like a single drone end? Yeah. It's in 3. This is 4.0 right here. 4, look, right? This PR from you? See, these functions are still such a freaking mess. 423 into 3. Okay, so we've mixed them then, unfortunately. Wait, why are they both here? Oh, it's in both. Okay, that's fine. You can do it to 3 then, Sam. It's fine. Historical freezing for self-play with great success. Oh, cool. Yeah, it looks like you guys are making all good progress, and I just need to crank Puffer 4 out for you. I'm gonna try to make this, like, not utter crap today. I have to make it so that this profiling is less invasive. The Puffer mug was a personal gift to me for my birthday. Need to finish off some coursework, more progress, awesome. Yeah, cool stuff, Sam. Trajectory track? Wait, what do you mean trajectory tracking? I think, do I like this? Figures of 8? Oh, cool. Very cool. Let me know if you guys start breaking the extra blades on the drone and need me to send you more, so that we get you your parts. I think I got you a pretty small kit. I think I got you some extras, but I don't know if I got you enough. From what I've heard from Drone Labs people, it's expected that you break a bunch of parts. Okay, let's see what it did. 0 parts so far. Goated. Okay, so yeah, the problem with these is that these functions are now stupid massive, right? Actually, I don't fucking Claude to do this, right? I should just know how to do this. I can ask. Oh. So there's using. But I like the... Obviously, you can still do this. Now let's see what the let's see what our functions look like. It's like nowhere near as bad, right? It's still a mess. Well, first of all, it did really stupid spacing. What happened here? Annealing rewards. Spencer suggests passing an action. Passing as an action. Wait, what? Why? No. Don't do that. You would literally... Okay, literally all you would do... Let me show you. Okay, you see this? This cosine annealing function? We use it for the learning rate. You would just throw it on the reward coefficient. So you would just anneal, cosine anneal the material reward to 0 over the course of training, and you'd resweep. Oh, I see what you mean. Just as a hack to get the coefficient. Yeah, you can do that if you want. It's going to be a little awkward though because you don't want that bot to output it and you don't want to mess up your buffer spaces. I think he was just coming up with a quick hack to communicate it to the env. That would make sense. Okay, I didn't break anything so far. So now here's the question, right? Yeah, we've got... This is super gross. You see this, like... It just passes struct. No, because they get repeated. This is the main chunk of the code that I want to be, like, less bad. Alright, I gotta use the restroom. I gotta make myself my morning protein shake. I'm gonna be a few minutes, and then we're gonna be deving the rest of the day, okay? And it's gonna be a little bit weird today because This is basically the how do we clean this up so it's not such a mess day. And there are a few pieces of this that are like actually requiring some thought. And then most of it's going to just be little bits of fiddling here and there. We'll see. There's also going to be, I'd like to get more multiple end bindings working and stuff like that. So we got a whole bunch of time today. I'll be right back. Okay. Hey guys, we're back. I'm gonna be ridiculous today because I'm feeling kind of sick and I'm gonna keep myself warm. Also, literally everything in my body hurts. Literally everything in my body hurts from all the training. So, I'm gonna be ridiculous in a bathrobe on stream today. Too bad. Protein hot chocolate. Yeah, I don't know. I feel a little bit off. So I had an idea though in the process of doing this. I think, a decent idea. So the signatures are just getting way too long, right? No, I didn't lift too heavy. Sore is not bad. I'm not hurt. So I'm super sore from hard training this week, and then I think I also I got exposed to some pathogen I'm fighting off. Here's what I'm thinking though, guys. I think that these signatures to the functions, we can actually keep it functional or whatever. We don't have to pass PufferL, like this God object. We don't have to pass this. But what we can do is we can pass, we can make this, for instance, an arg, and like this. Yeah, I'll show you what I mean. Here, Claude will do it. This is literally I think IntelliJ would already do this, but obs. Hover. Go. There's one other exploration thing, Jess, but just that. Like Puffer 4 is taking so long, I want Puffer 5 to be a more directed algorithmic update. Um, so I guess just one good way of putting it would be if you can get something that looks more like exploration is proportional to the minimum of the if you get exploration like there's this exponential factor in terms of the number of random actions it takes to get a reward, but then there's this other factor which is the number of states that there are to cover, and you should be able to get exploration proportional to the minimum of those two rather than to just the exponential like random action one. So there's essentially there's this very quantifiable thing that has nothing to do with this like high level lofty view of exploration. That's very easy to test directly and that I expect to have strong transfer to many ends. I have an active collab on it as well. That one is not yet public, but will be. This is nice in the sense that this doesn't really change the code one bit, but it does clean up all the SIGs. I'm gonna have to see after this what it looks like. I guess whether this is good or not is going to depend on yeah, this is going to actually quite well depend on what functions need access to what buffers. Minus 63 lines is always nice. Okay, so it didn't update any of the 6. I'm trying to think why I'm doing this and why this feels good today. Honestly, I think it's because of the coup de graphing, right? I think I just don't like well, it's the coup de graphing and the testing. I don't like the idea of having to recreate PufferLib for testing with the ends and everything. See, I don't like this is getting longer, this call, but I think it's gonna like, I think this will get shorter. Final struct. Okay, so now what we'll do is yeah, ultimately the reason for this is profiling, right? I think that's because what I would normally do is I just not have this be a function and I would just inline this code, right? Like, why split out a function when you can just inline the code? But in this case, it's so we can profile it separately outside of this. Hey, welcome. Okay, we're gonna see what this looks like afterwards and if this is actually easier to read. Essentially, the entire point of doing this, let me kind of explain. So the reason that things are like this, right? Normally, if I were just writing this, I would write the code top to bottom and I would not break out separate functions for things that are only called once, right? Like, why have a separate function where you have to deal with all the jank of the signature when I can just put a comment that says train, like copy train graph stuff, or no comment if it's obvious. But the thing is, because I need to profile blocks of code like this, and I need to be able to profile them not just during training, they do need to be split out into functions, which means that you do end up with signature jank. All this would be the signature otherwise, which means I need to start grouping things to make the signatures less gross. That's why it's a pain. And then the goal is ultimately, we end up with something that is no less readable than the original code, no slower than the original code, but is also able to be profiled relatively easily. Because otherwise you end up with 2,000 lines of train code and 2,000 lines of profile code. I don't like adding, values.device is now rollouts.values.device. I don't like this, so we'll see about this. This is going to be an iterative process. We're going to have to iterate on this a few times. We are losing code here, which is a good thing, in the process of doing this. Hey, user. This would actually be amazing if this were just like 10 seconds instead of 3 minutes. It's still very useful, but just less so. I kind of have to keep myself active thinking about. Yeah, some of these things are like weird. But we're losing code, which is good. Spacing is just god awful. Okay. Let's see if this still builds. Row and CT. And hang on, puff advantage. Let me see. How would you do that? It's time dependent, man, right? Calculating it once. Wait, calculating it once. Isn't it per sample and time dependent, dude? How could you pre-compute it? Hey, rookie. Lecture on optimizing writing good code. Buy your course. No, what do you mean it's not? Wait, this is one row, right? And then this is importance of t. Right, so the importance tensor is the same size as values or rewards, right? And then you need to do a min. Ratio is always 1. What ratio is always 1? Oh, but the ratio shouldn't always be 1. The ratio is not 1 after the first call. Initialized. Yes, so it's 1 on the first call. But then when you recompute it, right, the whole point of doing this is that importance isn't always 1. The entire point of doing this is that when you do the second update, so you do your second optim step, it shouldn't be 1 anymore. It's V-trace style importance. It's V-trace style clipped importance. The fuck is what's broken here? Yeah. Yeah. And we'll clean spacing. Okay, same speed, still works. $17, okay, we're minus 100 lines of crap. This should help. Just like get rid of these absolutely gross function sigs. I'm gonna try something after this, which is gonna be I'm gonna just try to like stick comments in various sections, and then tell it to go through and apply the changes. Because this like back and forth for term interface is so bad. I want it in the editor, so I think I can get pretty close. Okay, nice. Well, the thing is, I hate that it's taking you out of the editor. Like, oh, you shouldn't be in your editor editing code, right? The whole interface of it is just very anti-human. Like, the model's good, the people who made it are kind of shit. Hmm. Yeah, honestly, that wouldn't even be that hard, Jess. Oh, I see. I have the graphable functions intentionally like this, don't I? No, I have the graphable functions like this by design. It's quite bad. Okay, we'll have to look around a bit. I see why I did it this way now, at least. Yeah. This is nice, though, because this puts me back thinking about stuff. Hmm. How do I want to do this? You see the problem, right? The problem is that we have to graph a bunch of different functions with different signatures. So I just made them all take PufferL, because that's easy to graph. That's irritating. It's very irritating. Okay, I think actually, well, we've identified the main thing that's making this difficult to clean up, okay? Maybe if I just talk through this out loud, I'll get some better ideas. So, here's the issue, right? In Puffer 3.0, I just wrote the code top to bottom as simple as possible, not breaking out functions only used once. This is really nice because it's succinct, it's easy to read, there's no additional structure to learn. It's like pretty close to clean RL. It's actually really, really solid, and it's good for like larger pieces of code than most people would say. Now the issue is, well, there are two things: we're profiling stuff and we're CUDA graphing stuff, right? So they both cause sort of the same problem, though CUDA graphing it makes it a little harder. So first of all those chunks of code, um, like all the different chunks of code that need to be profiled need to be split out into functions so we can do that. Now, for the most part, these chunks of code that we're profiling are also being CUDA graphed, which means that we need to call them at startup time, and they need to be called with the right set of arguments. Now, I have this function for CUDA graphing, right? I do have this function for CUDA graphing, but the way I did it, where is it? Where's this trace? Capture. Yeah, capture graph. So you see how this function works here? And this checklist is because if you screw up this function, you're not going to have a fun day. And the main problem with this function is the call right here, which is PufferL. I can punt on it very easily in the meantime. Why are you not using a bitwise operator? Where? What? What? Huh? What are you talking about? Hmm. We can definitely punt on this for now. Let's go up to where we're going to capture the graphs. To make sure the right signature. Dude, you make statements like that just, they don't, like, this doesn't mean anything. Like, I can't think of any reasonable interpretation of your statement. Like, a bitwise operator to make sure the right signature is called. Like, what? Okay, that will work. That one will actually work. Let me go look and make sure I didn't mess anything up with these, though. Let's see how that likes it. And graps. I think this will be good. So the point here, I still don't know how to fix this, but I think that this will at least let us see if it's worth fixing. Because we'll basically at least get to see what the test versions would look like. Okay, it takes graph. That's good. That's what we want. That actually cleans it up a lot. Ah, man. Rollout, copy, call. Got rid of the asserts, but that's fine. Minus some lines. What the hell have you done? This is why you don't auto accept crap. This takes... That's a much more reasonable sig though, right? Better. My 70 lines. The lines aren't everything, but it's I take it as a good indicator that the code is getting shorter as I'm doing this, not longer. If I just click. This is way better, right? Simple. Okay. We'll see if this looks cleaner. You better not be slower. There we go. 10 mil. Alright, same thing. It should be. I've just moved some stuff around. Let's take a look at what these clothes look like now. That's weird. Something like this, though, is fine, right? And these SIGs are way easier. And all these hypers, well, will get moved. That's fine. Can do that. Some of these are still weird. Forward. Yeah, so it just did this weird thing here. Now it's directly here. Code will get into be much better shape. Yep, this is what we want. Moved all the hypers into their own section. Oh, and look at that. We've got minus another 60 lines. Just from like merging signatures and redundant things. This goes away, and then yes, good. Well, fine. 1853 lines. Are these counts actually accurate? It should be getting substantially shorter. It's fine. I think some of those are going to end up having to get moved back, but mostly it's good. Okay, this is like a ridiculous number of tokens on basic refactor. Come on. Saves a little time though. Well, that's annoying. Yeah, because we have to do this hypers. I don't even know if these things need to be exposed, though. And we might just not end up exposing all this crap. Main thing I want to look at is the function segs. Okay, it's fast. Cool. Now, the main issue that we're going to have here still have to make these functions, right? Wait, do these have to get tested from, Oh, wait, no, we're totally fine. Because these only have to get tested from the Torch API. So yeah, we're totally on the right path. That's quite good then. A few things in here still. PufferLib looks better. Let's finish getting all of these signatures to be reasonable, and then we'll see what we have left. Pretty good. Ah, I see. This is okay. Compute puff. It's pretty simple. Now what do we think about this section? And then we'll make my other edits here. Fold some stuff back in. It's starting to get cleaner. It's just going to take a lot of work. There are like too many sources of just mess. No, you don't need to update the Qt thing, dummy. I see. Yeah, let's do this. But then this keeps rollouts 10th advantage side, so this is still fine. Okay. Let's go mark some stuff for let's go mark some redundant functions. Too many of these little stupid functions. So we're refactoring stuff massively today. Okay, after this one, we should be able to actually see something and assess whether we have something reasonably clean. Nowhere near done, of course. Nowhere near done. Better than nothing, though. Okay, I think we're happy with this. Nothing broke. Oh, was I missed? Yes, Anish, hello. Okay. Oh, this is so funny. I was thinking of this exact thing. Wait, what? Oh, this is not the direction I had. Okay, his mind is not in a good spot right now. Yeah, his mind is not in a good spot right now. Spends too much time on X. Alright, what do we have here now? Mm-hmm. Oh yeah, this is way better, right? Was no longer used. Yes, he is. We don't need this. Don't need the policy in here anymore. Nice. I will say though, for Hots, I don't think he's making it up for clout or anything. He's from what I can tell, a pretty genuine guy. I think he's just spent too much time reading Twitter, which is currently a total cesspool. Very nice. Let's see what our rollout function looks like now. As a university student, you should learn what interests you. Yeah, they all went to Blue Sky or whatever. It's mostly all this hyper profile stuff that's in the way of me reading the damn code, right? Let's see. Thing wasn't graphed. I mean, this is way easier, right? We've got a screen of code for rollouts. It's the same thing, right? This can also just be an int. It doesn't need to be an int64t. It's this thing here that's a little annoying, right? Okay, I think the next thing is to figure out the graphing signature. Because this is not bad already. Like, we've already cleaned... This is, like, way better than when we started today already. There's still so much left to do, but way better than when we started, at least. It's pretty similar to the old profiling system as well. I could probably add like a profile switch or something to make it slightly lower overhead. We will see. Quite good though. Alright, let me figure that signature thing out, and let me go grab myself a nice mug of tea or something. All right. Oops. Freaking shoulders acting up as well. Keep it warm, maybe. If I look up graph rollout, okay, this just gives you rollout copy call, right? Graph rollout copy call. The thing is, this is the graph function. I really hate the way this is right now. I don't think it's gonna come up with much. I don't think there is a good way around this unless there's some disgusting C++ variable args shenanigans. Do you start over? What do you mean? Do you start over? Puffer's way too big to do that at this point, man. I scrapped substantial sections and start over. Or like in this case, right, this update, all the C++ is new. There was no C++, so it's a port that's brand new. Generally, they're pretty heavy changes, but you can't just start over. Puffer's too big. And it's not like too big in the sense it's too much code, but there are too many subtle things that you really need to get right or everything breaks. Template the capture function? No, we're not fucking doing that. Screw you. ASPY. If we do option 1, Look, I'm feeling a little sick. I'm super freaking sore today. I'm wearing a damn bathrobe on stream. I feel like it, alright? So deal with it. One. I don't like this, but this will take out this indirection annoyance. Well, first of all, you can make a basic website with just HTML. And then you'll probably want some very light CSS and some light JS, and you can get pretty far. So pretty much the fastest way is to not try to do all of those, like to learn all three and then make a website, but to rather write the simplest, dumbest HTML site you want, and then learn the minimal thing you need as you're building like real projects. Yeah, so this is what I figured. So this is gonna have, this has the capture calls in here, right? Yeah, like this. I know I can just I'm making a website with AI in it. Where do I learn ML? Well, that's a much longer thing, right? What the heck does a website with AI in it even mean? There's very little AI deployed on websites, actually. We have one of the cleanest examples of that. If you check our puffer.ai, we have all of our agents for the games directly on the website, but that's not JavaScript really. Like, yeah, okay, it gets exported with some JavaScript glue, but for the most part, it's just C that gets compiled to WebAssembly. So, I mean, the first thing you're going to want to do is figure out, like, whether you're asking the right questions. What? Then that's just an API hook. That's not learning AI. Like, What you're actually asking is how do I set up a super basic website where I hook in the API for some whatever language model. Okay, that's actually pretty nice that we don't have to store that. So this will be slightly more code here, but it'll be more explicit, and we will remove we'll remove a few redundant functions. The heck is this? Yeah, that can go away now. Well, how would you do it? I have no clue. I mean, the biggest mistake I made was not doing lower level earlier. Honestly, GPU dev I've just been picking up in the last few months. Just like learning how to write basic stuff fast in C. It really sets you up very nicely. Because the thing is, it just puts you so much closer to the hardware that you understand how everything is implemented. It just gives you a very different perspective on programming and on how everything works. Okay. So let's see how this looks, right? So we have slightly more code here, but we actually have the call signatures now, right? Which is nice. Get the graph policy. I bet you these RNG seeds aren't going to be needed. Start with books or docs, right? No, I don't know book. I'd written like one kernel. Look, it's pretty much like this. Where is it? So this was the one kernel that I wrote, right? So I wrote this saying, oh, this is literally just C, right? Like this chunk of the code, this just would compile and run in C. In fact, everything except this host device tag, right? This just runs in C. So this is a super basic kernel. And from here, I had to figure out how to set up a basic launch. So this was docs, right? You know, just have to invoke a launch. And then there was some setup for this required, but this was pretty simple. And then I said, oh, okay, well, you know, basic kernel dev is really not any different from writing C. And then of course there's some extra stuff that you have to think about because GPUs don't work the same as CPUs when you do things that are more advanced. But you know, this gives you a pretty smooth way to start. Like if you know low level dev, it's not really a hurdle is what I'm saying in order to start on stuff like this. Right? Like where's the next kernel, like mingru? Like here's the gate kernel. This is also an element-wise kernel. And I wrote like a couple smaller little kernels for this. I hadn't done templated stuff. I hate templates, but I had to apply like one templated thing here for a couple type supports. And then there are a few more sophisticated ones, right? So it's all incremental. But like the point is, this is not me learning all of GPU dev, right? These are very basic kernels, but the point is I'm already doing some pretty ridiculous things with just like these very basics. Hey Tim, we're currently refactoring PufferLib the C++ so that it's actually reasonably usable and we can get ourselves towards sort of a pre-alpha type release. there a way to test them right away? Yes. You have to set up NVCC. So as long as you have your compiler, then yes. But like the point is, it's the point, country, is like if you just start with a very minimal version of whatever it is you want to learn, it's actually quite straightforward to learn by doing in docs and stuff. Um, Big formal courses and books I find sometimes helpful for filling in gaps, but less helpful for learning because it doesn't get you working on something end to end right away. It often courses are structured to like let you fill in little chunks here and there, where what you really want to be doing is building end to end things on your own as quickly as possible. Okay, we now have one screen of code for our rollouts. Congrats on 10 mil, thank you. One screen of code for rollouts is not bad, right? Like, this is getting towards something I could see us shipping. Not quite, right? But pretty close. What do we have for train? Is this not graphed? Doesn't look like it. Yeah, see, it's not even doubles. See why you're profiling so heavy? Yeah, exactly. Well, it's kind of the other way around where I have to refactor it this way. It's not just because of the profiling, to be fair. It's also because of coup de graphing. Even without this profiling, I'd have to do it this way because of coup de graphs. So I may as well get a 2-for-1. Let's get some more reasonable types in here. We don't need friggin' doubles on everything. Only thing that's gonna go above will be steps can go into billions, right? On that, pretty much everything's set. Oh, that's so funny. I swear it's the best damn game. That's fine. Yeah, I don't see anything there that needs to be that's totally fine. Alright, man. Wait, why does this one have? I literally just checked that. Compute puff advantage. Oh, look at that. You see, it takes doubles here, and then it converts them to floats anyways. So we may as well just use floats. Yeah, that's nice. C++ using doubles for everything by default is just so gross to me. Like the style just being double for everything is bleh. Okay. See if this runs. Okay. One thing got overconverted. Give Opus a try. No, I've been using Opus. It's fine. Like, it's just that the way that people wanted me to use it was completely stupid. Like, the model is fine and I use it. I use it probably for, like, way lighter stuff than people were expecting. Honestly, the biggest feature sell for me right now would just be speed. Like, make the model faster. Cheaper would be nice, but faster definitely. Oh, that's so gross. Wait, but this is... Hang on. I see. Actually, can I just do this myself? If I just do double, does this work? This is a stupid torch thing. Is an assert. Yeah, but I don't know why they like this. Where's my freaking error message, huh? What? Excuse me, where's my error message? Oh, in this CUDA? This doesn't need to be. Where the heck is it? Wait, compute. Oh. Let's see. That's so annoying. This is Torch just being stupid. Double, double, float, float. Oh, dummy. How? But same thing. What? Okay, I'm just not seeing shit now. Failed to import. Really? Puff advantage CUDA. The sad thing is I actually think Claude would have fixed this by now. And my solution around this is not writing this type of bullshit. Like, look at this. How on earth could have anybody have thought this is like just putting the signature in a string like this in a macro? So bad. Oh, I know where it is. It's this, right? I got it. Uh, yeah. Claude would have actually gotten that before me. I mean, you see the stuff it is, though. It's like, it shouldn't be built that way in the first place. Like, I didn't expect to have to do that because it shouldn't be this way in the first place. Oh, for fuck's sake. Absolute garbage library, man. Use float in the string, but then double in the signature because float means double. Fuck off, meta engineers. Why did you do this? Okay. There we go. Let's make a quick commit here. Okay. Let's see what we have now. We should have something that's at least readable. We've got a reasonably small PufferL struct. Just make everything more explicit where tensors are involved. I think we'll end up with output args as well, so we don't have to have these freaking vectors everywhere. Yeah, because I don't like that this is in a vector like this. But I mean, it's been mostly a few things that needed some more subtlety to them, but mostly a series of very simple, precise transformations to the code base, right? Some stuff cleaning up types, a lot of stuff cleaning up function signatures, some stuff like grouping data into some structs. All right. Boom. Now everything is nicely typed as tensors. We got rid of most of the crappy auto usage. I really just do not enjoy any sort of C++isms. This to be way, way similar to our end of code. There. That's nice. Still works. Okay. I'd say this is way nicer. Way nicer, right? See what a rollouts function looks like now. Oh, this is a graphing code. This is still a mess. That's fine. It's expected. Void rollouts. There we go. Make sure this still works, and then we'll start on, I mean, there's several other things we need to do. Okay, this works. So the next thing JIT is infinitely better. Heh. Dude, their JIT sucks ass. I tried it. I tried it quite extensively before I did this. Jax is just an abomination. It has like no redeeming qualities. It makes you write awful code because some Google bros wanted to abstract kernels and abstract tensor ops out into Python. No, it's not. I've tried it. It produces slow fucking code too. I have no idea what you're talking about. I benchmarked it quite extensively versus Torch as well before I started all this. It doesn't magically give you this level of perf. People like it because they don't want to think about low-level dev. But it doesn't free you from thinking about low-level dev. It just lies to you and says that you don't have to think about low-level dev. It does speed up? No, it doesn't. I tried it. It's out of the box? No, it doesn't. I tried it. I tried all of that. I have several tests for it. It didn't fucking work. Torch compile also doesn't work. But then what happens is that half the time the JIT produces the same speed as Torch Eager mode. You're comparing highly optimized. Well, the thing with JAX is you're not intended to write any kernels. It's all Python. So when you try to go lower level, it goes, duh, you're not supposed to do that. We want you to JIT everything, yay! And it's just no. They don't even have a low-level API. If I wanted a pure Python learning library, I would use TinyGrad, which at least design-wise is infinitely better than JAX, and speed-wise is catching up quickly. Well, that's not the intended use of it? No, the intended use of it is for you to not understand what the fuck is going on under the hood, for you to type your shitty Python and go fuck off. Which is not what we do here, man. You need Palace. Oh, yeah, you need Palace. It's low level. I can write CUDA. Maybe I can just not deal with Google's bullshit. And I can just write CUDA. At least when I deal with NVIDIA's code, it's actually good. I don't like being tied to the hardware. But at least their code is actually good. Their compiler's a black box. Yeah, and I like it when it's not, but the thing is, Google's is awful. It's like absolutely awful, unusable. I mean, Jax is just like your typical Google bro, oh, we're so clever, this is how you should write software, and then they produce dog shit. Like, at the very least, I would say that Torch is a not particularly competent implementation of a dramatically better design. Okay. Still works. Not all Google software is it. I've yet to see good software. I'm sure they have some good engineers. But like most of their stuff is just awful, awful. Honestly, I'm pretty sure at this point the only one of the big tech companies that seems to write generally good stuff is just Nvidia. Like pretty much all of their tools that I've had to interact with have actually been good. Insight is undocumented. I've been using Insight and it's been great. They have really good help menus. Food is not undocumented, are you kidding me? Okay, this is not bad. Great rollouts, great graph train. Yeah. That's almost everything. That's almost everything, I'd say. Matrix matmul kernels. That's like the one kernel that actually has to be freaking stupid fast because everything calls it. I don't think that they do everything to blind you. Like, the thing is, the API is sufficiently low level that there's really not that much magic. If this were like, if CUDA were written by Meta or Google, there would be like, you know, some like memory copy manager view thing that you use to move data. I mean, they just here's your mem copy, here's your mem copy async, right? Here's your stream. You can like it's very nice and low level, such that there's really not that much guesswork. Like if this were written by a different company, they would give you a fundamentally higher level API that would just be big and bloated and a mess. What happened to big tech? You just weren't paying attention. See, PyTorch was actually very good when it was introduced, um, because the alternative was TensorFlow or Caffe. But then it kind of just kept getting more bloated, and then the design of compile is awful, absolutely awful. People from Big Tent went to OpenAI. Well, OpenAI was good when it was smaller. I don't know how their talent density is now. I mean, NVIDIA has kind of just been good. Like, none of this is recent. The thing is, it was always shit. It's not even in-shitification. It just was always shit. Like, as soon as stuff gets big, it gets to be shit. Like, not everyone at NVIDIA is good either, right? Like, it's their core low level, though. CUDA is good. And that's pretty much all you need. You figure what we're doing next. You think XAI? No. I think where we want to go from here with this. Yeah, like this type of basic thing, right? Yeah, this is weird. Why C++? I don't know, it's a terrible language. To be fair, that's not why it's a terrible language. Like, that's way far down the list. C doesn't have keyword args either, and like, it's good, whatever. It kind of does on struct creation. Why the hell is this static cast? Just not do. I mean, the thing is, it's not even about recreating the software stack. It's just most of the time you don't need a damn stack. You need like 2 things, and they grab 10. You know? should not break anything. 10 mil. Good. Yeah. Not breaking anything. Good. Okay, so actually I can give it something big now. I think I should do a little bit more on this before I try to get it to update the profile. Let's at least fix some names and shit, right? I'm gonna get another mug of tea. Because, like, the goal of doing this all was that we also were able to have profiling be clean. So I'll be right back and we'll do that. Also variable M's. Lots of stuff left. I'll be back. Okay. I do think we're getting relatively close here. I mostly just want to rename a few things and move some stuff around. Get rid of this crap. We don't need this. Let's just think about some names real quick. That's going to be the main thing so we can do the other refactor, right? I hate these prototypes, or these declarations. They're so bad. Let's see what's in each of these. Yeah, everything's like super inconsistent and crappy, right? Graph T. Oh. Train forward call takes graph train. Just graph train, right? Naming things needs to be easier. So then we also have this mini batch T. In fact, I do this mini batch T. Wait, graph copy. Train graph copy takes PufferLib. see. Let me look at all these. I think this is the complicated one. Because with the other one, if I ignore training, if I just ignore training, I could put everything in the graph buffer to be fair, right? Let me think about that. I think that the names collide. Yeah, the thing that's giving me pause here is that I'm having difficulty even remembering what the hell everything is in much my own library. That means it's probably quite bad. Hey, grats to priming. Mhm. Wait, isn't this mini batch T just redundant as fuck? Yes. That's what was confusing me is we had a redundant struct. So I was trying to keep things straight because they were actually the same. Oh, that's really cool. If that's actually real, that's pretty cool. That they have that good of a modding API. Yeah. That's like such a big win for gaming in general. It's really cool to see that this exists. I don't know. I like games for AI, but I also like games. It's nice to see something like that once in a while. Hello, yellow, welcome. Java? Yeah, I know. That's how I learned to program. This is from 2012. Do you still play indies? I was, and then I re-downloaded Old School RuneScape, so I've been playing that. That's just my favorite game of all time. There are only two games that I've sunk like an utterly stupid number of hours into. One is Old School RS, and the other is Dofus. I don't know. I've always just been all. I've always really, really liked the idea of MMOs. Absolutely love the work on Neural MMO. Thank you. I mean, have you seen Neural MMO 3? If you're coming from my thesis. So we have right here on Puffer AI. This is the follow-up environment to my thesis. It is about 1,000 times faster. It's more complex. And we have actually trained this thing on, I believe, 12 to 13,000 years worth of gameplay on one server. And this is now probably our hardest benchmark that we use for all the stuff I build nowadays. So I'm still doing Neural MMO things, and I'll probably end up having to make a fourth one when we eventually solve this, but this is only a third of the way solved right now. All multi-agents using the same algo? Yep. It turns out that most of the algo work in multi-agent just doesn't work, and you are kind of better off just running PPO normally. Okay, so this is way better. So we have an end buffer and a rollout buffer, and then the only question is going to be around this stuff here, right? So I guess I just want to go see what these three things are before I decide what to do. Train forward call. Oops. What's this? What is counterfactual regret minimization? No idea. Probably maps to something quite simple. Okay, so right. This is kind of irritating. Yeah, this is kind of irritating because Does it really work this way? I mean, it has to, right? New value.copy. I think for now it has to work this way. At least until we improve the algorithm. So there are a couple of these extra buffers that are quite inefficient that don't like fit anywhere cleanly. Incomplete information games, cool. Yeah, that does not interest me. Can I stick this in rollouts or not really? You'll see that the math only works under very stupid conditions or with very stupid bounds. Graph train ratio, graph train new value. Those don't need to be there, do they? Oh, yes, they do, you dummy. So this is actually MB ratio, and this is MB new value. You say this is MB ratio, this is MB new value. Yeah, that's why I'm confused. MB ratio. See, this is why I was confused. Search for inference time, poker RL. Reinforcement learning for science. Oh yeah. That's where we're going eventually with this. Not even eventually, within the next couple of years, Liberty. I mean, imagine that we have 1,000 times better RL than we had literally 2, 3 years ago. 2 years ago, even. Not quite there yet, almost. So, we have some options here. I can name this mini batch. So I could name this could be mini batch. Yeah, man, Ethan, that's completely irrelevant. And you're focusing on some of the wrong problems. I kind of like having this just be the batch, right? Buff, buff, buff. What this? It's not strictly doing what the value function doesn't even influence the policy at eval time. What do you want about? There, this should be better. That's clean, right? You have a buffer for environment stuff. Possibly we can even merge more than this. The policy is like argmax val. No, it isn't. What is it then? It's a sample. It's a sample from a probability distribution. No. Should be theoretic. The thing that you said doesn't make any bloody sense. Expected expectation of I guess return it would be. In deterministic games, that's not even true if you have an adversary in the game. It's only true in... Is that even true? It's still not frickin' true in deterministic games. Maybe it's true in deterministic, single agent, fully observable games, maybe. Like the thing here is you've entered a regime that demands a lot of precision. So if you're going to try to do something in this space, it demands precision. There are spaces where you can hand wave things and still have stuff work, and this is not one of them. Sorry, it's not correct. Your policy in rock, paper, scissors should not be deterministic. Rock, paper, scissors is deterministic, your adversary is not. Proof by counterexample. See, I mean, like, you see how it takes me, like, literally 5 seconds to think about these things as well? Like, this is what I mean by, like, if you're going to be thinking about things in this space, you need to be very precise about things. Now, I have great news for you, which is if you want a space where things are more empirical and don't need as precise definitions, if you just take general games or general environments, basically no theory holds, because the vast majority of game theory as applied to RL, POMDP theory, whatever, it just breaks or gives you really crappy bounds in sufficiently complex environments. And then the things that end up working are quite simple and determined empirically. Those players are deterministic. No, it doesn't, right? Because determinism is almost always referred to as a property of the environment. And by the way, you can get got basically even in deterministic opponent, deterministic environment, if it is partially observable. So I can give you a deterministic opponent that's just using a seeded random value for the moves, but you can't observe the seed, then your optimal policy is still stochastic. So there are tons of gotchas. You see how that works? If from your perspective you can't observe the seed, so it looks like the opponent is playing randomly, then your optimal policy is also to play randomly. Ten seconds. Very nice. Like a lot of the holdup in the field, right? A lot of the holdup in RL is people being too precise, where the precision doesn't matter and kind of getting lost in the weeds, and then people not being precise enough, where the precision really does matter. And it's important to know which is which. For instance, I would say exploration research is an area where it's been held back by people not being precise enough with their definitions about what they're even trying to solve and thinking about the problems. And then, like, algorithm development has been held up by being too precise about definitions of various forms of MDPs and POMDPs that don't actually map well to the problems that people care about solving, or that have very bad bounds. You can fail in either way. Well, this is quite nice, right? Which is some equilibrium. Last three words, what does that mean? Maybe you care about other Nash equilibria is my point. So that's something about strategic diversity in a game. The simplest, most effective method for this thus far has simply been fictitious self-play or historical self-play. Possibly some stuff with the exploiter agents in the Alpha Star League. I think it's probably overkill. And also, most real games don't look like Nash equilibria either. Policy function learning inefficiently? No, I don't think that's the case. That would be something that you'd have to demonstrate, and I don't think you can demonstrate it because I don't know if it's true. ES works better. Yeah, that doesn't make sense either. There'd have to be a precise experiment, like you'd have to have a specific experiment set up. Naive ES as it is now is also just never going to work. Let me think. 242. I think we can try to get the... Well, we can have it update the test. Yeah, that's quite cool. It means their mod API is pretty good. Oh, they actually put the dragon in, that's funny. Whoop. Okay. And roll out and speed args. Let's just wait on everything else. Forward args. Profile kernel, run train forward call. Args policy. Yes. This should now be substantially simpler, right? Here's the restroom real quick. Oh. Ooh. Hmm. Let me see about this. Quake 3, DeepMind. Link the paper. I swear if you link me the capture the flag paper. Capture the flag. No, Capture the Flag is DeepMind. That's the well-known one that's based on Quake. OpenAI's Hide and Seek, which is also Emergent Tool Use, same project. Okay, so it just duplicated all the code. It's CTF in Quake 3. Yes, I know. They modded Quake. They just changed some of the graphics. It's the same Quake gameplay, I know. The reason I said I swear if you linked me in that paper is because they didn't use evolutionary strategies in the way that you described. No, it's not a bad paper, but I don't believe that you read it. Because that's not what they use ES for. They use it on a tiny little network optimizing rewards. They basically use it as a glorified hyperparameter search over reward coefficients. Not for the whole net. I didn't? Well, if you didn't read the paper, then why are you citing it at me, right? Unless you had a different paper in mind. I mean, you said something about like, oh, you know, what about like ES being more general because of this paper? Suggesting it. But you're suggesting to me a paper that's interesting that I've read and you haven't. For a reason that you don't understand because you haven't read the paper. Like, you see? Like, if you read the paper and have some like comment about, you know, the thing, oh, could we do this with it? You know, that's one thing. But if you kind of like point to a paper as like vaguely, yeah, they use ES, they said it would work there, but it's in like a capacity that doesn't make any sense for the thing that you're suggesting, that's another thing, right? Like, if you're interested in this stuff, it's worth the time, it's worth investing the time to like at least get the background to be able to speak and think clearly about at least a handful of the major works in the space, right? That's one of maybe 10 papers that's actually worth reading. I believe I have that directly in my guide as well. Hello, welcome. Why is it not ES? God, look, dude. Look, I haven't read this paper in I don't even know how many years, and like, we'll see how quick this is. Da 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 da. Internal reward. All right, right here. This is the thing that they use ES for on it, right? If I recall. They use game points, PT, winning signal. This goes here. This goes to internal reward. That goes to policy. Where's this stupid thing? The heck is it? Game point signals. Where are the features to this thing? I think they're in the appendix. If you go look at what they actually did, Come on. I publish papers in math. Then you should be able to read it pretty easily. Right? I mean, if you're interested in this space, then you should just be able to read some papers. Okay, look. You see this? So this is the vector that they give to the agent. All right, they just made like a bunch of booleans here. And then they use, I think it's one layer, right? It's either one layer or a very small network. And they used ES on the weights of this thing. So basically all that this thing does is learning some very simple function of these. So they're using this as a glorified hyperparameter search, not for actually training the agent, right? So this is completely different from learning like the actual weights of a policy with ES. This is just them like wanting to do some genetic thing and deciding to chuck it on their reward optimization. And this is featureizing, by the way. So these are manually chosen features. So they could have just as easily like manually chosen some reward components directly, right? And then they decide to do ES over this thing, which is ludicrously inefficient because they have unlimited DeepMind compute. Like, they would be way, way, way better off if you didn't have this crazy amount of compute to learn this function, right? You would just, like, take all these components, and you would just, like... Actually, I think it's literally the same thing, because... Yeah, it is. It's actually the same thing as what I'm saying. Isn't that nuts? So I think it is literally just they learn one weight for each of these things. You would just do this with a hyperparameter search. You don't need ES at all. So I know this because DeepMind loves to do shit like this. They like to use the super sexy technique that sounds super fun in general when it just like whatever doesn't like you can do it if you have unlimited compute, but it doesn't make it smart. Yes, neural MMO initializes the same net among all the agents, and it does here as well, except for this tiny little thing plus their leagues, which is independent. This network is just them doing different reward shaping. It does not depend on ES. They use ES instead of just doing hyperparam search. There you go. And actually, just to show you, if I check my article here, watch this. I only recommend 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I recommend here 11 papers here in my read these papers section, and this is one of them. Yes, but the thing is you're conflating two things, right? You're conflating their tournament setup with their use of ES. These two things are completely independent. The tournament setup is like sort of similar to the Alpha Star Leagues thing. Doesn't depend on evolution at all, and is to be determined, competitive alternative or not, with historical self-play. It's certainly more compute expensive. We don't know if it's better. I'm gonna add these to my reading list. Yeah, it's all in that article, man. If you just follow through that article will take you through the process of learning RL. Multi-agent stuff with tournaments. Yeah, so multi-agent stuff with tournaments, the problem is it's slow. So you can do it, and it's reasonable, but it's slow. Historical self-play is dramatically faster and often good enough. It was good enough for Dota. So you can do full league stuff. It's guaranteed slow though, because you're splitting your compute among many different policies evenly. Whereas with historical self-play, you take maybe a 20% perfect at most, if you're doing it correctly. I believe that the other paper I suggested is literally the first one, the OpenAI 5 paper. In my view, that's the best paper in the field. We need Puffer 4. Deterministic, then if it's determinized early, your hypers are bad. We need Puffer 4, yes. We do need Puffer 4. I do need to focus on this a bit. So, right, I was on this thing. Okay, so I'm going to let it do this for now. This is basically us not being able to include the file, which is why this is putting all this crap here. So this is now duplicating shit in two places into the tests. I mean, it's a reasonably interesting discussion, E10, but it's like a rather uninformed discussion. Like it would be much better if you read the paper, right? And then decided whether there was stuff that was interesting to discuss. Like the only reason I'm being rude to you now is because you're trying to discuss something that you haven't read. Otherwise, I'd be more than happy to be discussing it much more politely. Yeah, so this is literally just copying code over. What are we working on? I'm a newbie? Then follow my guide, man. My guide would have had you reading this. Right? My guide is like pretty short. It doesn't give you like 3 years worth of reading. I promise you that if you go through the list there and you like do some of the stuff that's there, like you'll be able to have way better discussions. You'll be shocked how quickly you can learn this stuff, especially if you have math background for it. Okay. So I'm gonna just let this copy this thing over because this is literally just it's basically duplicating all the new code changes into profile because we don't have a reasonable way to include the code without just copying it yet because we got to refactor stuff. But I want to at least have this runnable, and then we'll see what we do from here. What we're working on today is refactoring the PufferLib C++ code for Puffer 4 because we hit the speed target, but it's a total mess. And we have some reasonable profiling now. The profiling is super verbose. It needs to be way shorter. I refactored a bunch of stuff that should make it easier to profile. And first, we're going to do the verbose version with the new style. And then I'm going to actually have to go figure out how we move some stuff around so I can actually include the code from another file instead of just like duplicating stuff. It's actually kind of annoying in C++ to be splitting things up to different files because I don't want to generate a whole bunch of redundant headers. Read the puffer algorithm. The puffer algorithm is very simple, right? It's like a very simple set of changes on PPO. It's not meant to be like super intellectually impressive or anything, but it does work, and it works very well. I'd say as far as like, if you want something that's a little bit more impressive algorithmically, I'd say protein is something I'm quite a bit more proud of. Like our hyperparameter tuning is pretty cool. But yeah, for anybody watching, if you want to be able to like discuss this stuff with me live, it it's really it depends on what background you're coming in with. But if you're able to like start on this stuff and you don't have a whole bunch of background to do before you even start, the actual content of this article is not that long, right? Like there's some stuff for Puffer, building a couple basic hyperf ends. This just requires like very simple systems dev background. One undergrad course is plenty. Um, it takes you through like building a slightly bigger project that you could actually PR. It gives you all my references, like the references to all my favorite papers that I think are actually worth reading. It gives you some really good general advice on how to think about things. Links a few cool applications, links a few algorithms I'm thinking about. I actually think that this is a bit dated now, where like these, I think these were questions I'm thinking about, right? And this one I think I've more or less resolved, and I don't think off policy is actually that worth it, and I don't think that model based is that worth it, at least not in the way that's presented here. Search still questionable. Infra way more important at the moment. There you go. I should do an update to that guide. It's pretty much all up to date except that one section on essentially my current thoughts on interesting open problems in research. Okay, cool. So this says that it runs. Ah, and the namespace is not here. Actually, do we not? We actually should. We should actually have the namespace in here. Less than 1% of people will do the complete thing. Well, I mean, doing the complete thing is like, if you want to actually get into research and be, productive in the field, then I provided a way to do so that is like dramatically faster than the normal recommendations. Can only do so much, right? I can't like dump all RL knowledge to you in 5 minutes, right? I made it incremental, where like you can do a good chunk of stuff in there in a weekend if you have even basic systems dev. Like you will learn so much just making a couple environments, reading a couple of the papers in detail. You learn a lot very quickly. Weird. I'll let it just do this because this is all going to get removed in a second. But I don't want to have to think about this until we do the next chunk of it. Yeah, this is just C++ jank. Let me start thinking though about how I'm going to actually split this up so this is reasonable. I think I just need to include the damn C++ file. Learn what not to do. They're not interlinked with Puffer, dude. Look at my list. Did you check the list? Like, look. Dota, OpenAI, cool. StarCraft 2, AlphaStar, DeepMind. DeepMind, OpenAI, uh, DeepMind, OpenAI, DeepMind, Meta slash whatever. OpenAI, but really more Schulman personally. Schulman, and then original DeepMind. They're all OpenAI and DeepMind papers because that was the golden era. I didn't work at both of those places. I was at OpenAI for like 6 months. Yeah, but other than this one really kind of cool environment, like the vast majority of the papers, the good papers that actually work, are from OpenAI and DeepMind. Techniques you have or want to implement. There are a bunch of different papers, though. There's some core algorithm work in there. Um, there are like a number of different like large scale problems that just show what it actually took to get RL working on a very hard problem. There's some cool environments in there, right? Some cool concepts on building useful environments. I definitely don't want to implement most of the stuff in there either, especially the DeepMind ones have like a lot of just fancy stuff. Just do this. Okay, this is like brain damage. So what I need to do is let's get this thing running and then we'll have it remove all this duplicate code and then I'll actually be left with an amount that I can check manually. Namespace, okay, so let's actually just do it this way. We'll just have it include the file. Wait, why did it do it this way? Is it 1:2? Literally did it wrong. Weird. Whoops. Wait, what? No, okay, that thing, I freaking hate this thing. You know what? Let's just do this. That's what I was gonna do next anyways. It'd be possible to replicate StarCraft Dota. Yeah, so that's the thing, country. You'd have to write the end. If you wanted to do it at our normal speeds without spending a ton of money, you'd need to have a fast version of the end. I mean, presumably we could at least get it faster than they have it. But I don't know how, like, I don't know what the cost would be. Because you need a ton of samples. What? Oh. We'll let it do this because I'm going to move it after anyways. I'll probably just make like a bindings. Fine. Like, you see what stupid stuff, though, it recommends? Like, it just decides to guard this with this so that it doesn't, like, it can include the file instead of deciding, hey, maybe this should go in the in a bindings file. Okay, you see this giant delete? This is actually correct. This is because all of this crap was being duplicated before. Copy pasted because of the janky includes. Should be much more of this that can be deleted. It's probably not going to realize it, though. I'm actually surprised it's this bad. it's very funny because like this thing doesn't feel smart. This thing feels like careful, like relatively careful, not smart, and that it can apply precisely described transformations to code, and it can do so in a way that it will be more careful than I am just like sitting here being kind of tired. Um, but I definitely don't trust it to do anything other than that. But hey, precisely described transformations, that's already very useful as a tool. Too many dependencies, yeah. No, we're not doing that. How many sample games do you need for what? Sample games? I mean, Dota, they trained on a huge amount of data. They trained on, I don't know, it was like, I think they said they trained on, it was like 100 some odd years per day, but then they ran it for months. So, I mean, we actually can get that scale on one machine with our M's, but not with like slow M's, right? Okay, this I'm happy with. We can do this. Can just move that over. Get rid of that. Why the hell would you ask it to do git commands in the first place? That sounds like a terrible idea. Replicate the mechanics up into yeah, exactly. It's just we write a fast version of whatever the target is, Liberty. Because like the thing is, most stuff that is slow for no real good reason. And it turns out we can just make stuff fast. Nice. That sounds awful, Ethan. I'd way rather do the opposite. Writing unit tests all day sounds no fun. Though I will, it makes sense for a couple very niche things, like, for instance, if you have numerics checks on kernels, but then you still don't want to just let the thing write a kernel. It'll screw up. So I think still I probably use the model more in writing the test than I did in writing the kernels. Like, in the sense that I had to do way more manually of it. You can't let the AI write the kernels, they fuck it up. Okay, it doesn't work, it's completely wrong and irreparably, like, stupid. What do? Well, you have to write it yourself. And what ends up happening? What the hell? Oh, that's fine. Yep, that's actually good. Yeah, you're allowed to do that. Need to read a bunch of code? Well, then you read a bunch of code. Does our profiler build? No, it doesn't. Yes, this is no longer needed. Good. It's not reading that much faster, actually, at the moment. It's kind of slow. Do that. I think that'll still conflict, but we will see. Then I have no idea what it's doing for the rest of the time, because if it could go through that many input tokens, it should be much faster. I think it actually takes it several minutes to read that amount of code. I don't know what the actual token per second is on this thing. Simple logic CPP, huh? We'll be right back. One agent is stupid enough already. If we're calling agent thing that reads code in loop. Whoops. Stupid. Fine. I think that's it for Vec. Probably kernels. Narrowing conversion errors. It should not be an N64T. No, dude. I can tell you've outsourced way too much of your thinking. Like, there's a reason I do things this way. And this is the most I use the model, by the way. Not remotely this much if I'm like building a new env or something. This is because I'm refactoring highly redundant boilerplate heavy crap. Right? Okay. Compiler. Compiler. Yeah, something got messed up in the setup. Most likely. Maybe I can do two things at the same time and then do them both badly. I'm focused at the moment on how this thing should be restructured so it doesn't make a mess and need a bunch of dumb headers. Should be able to just have... Yes, this is what needed to move, that's fine. Oh shoot, the dictionary. Okay, it'll need a wrapper. Yeah, it'll need a small wrapper. Why badly? Because you'd be doing two things at once. Are you waiting or thinking? That's the trick, is that you have to still be thinking about it. Or you lose context on the problem. So it'd be good to not have this in here anyways. If the agent was at 1 token per second, I wouldn't use it, dude. It wouldn't be useful at that point. Yes, this is correct. This does go in the binding. A little sketchy on the gill stuff here. Okay, this is what we expected, right? It's not. I think we're gonna hit a problem with the gill release. Build this thing. Try to build torch. Okay. This is the annoying thing. So I don't know if this is going to be too much is the problem. What happened? I saw that some people got hired back. I didn't see much else. Okay. Now I suspect what's going to happen here is that the scoping has to be more precise. Maybe not. This one we can fix. Okay, that actually does work. Very nice. Do we train stable? We do train stable. Solid. The other choice of joining. Well, I'm not joining them, right? Like, I would have gone and joined one if I wanted to. Exactly, like I got my own thing. I'm way happier doing Puffer. Okay, something screw happened with Muon. $1,500 lines. That's way better. There's still much more to be done, but just this, right? I mean, right now, Puffer is it's the small model RL lab, right? Like, nobody else has anything remotely like this in our area. And Claude since then. And, uh, since, like, the second stream. I don't use it for everything, though. Like, this is a particularly good application because it's just a bunch of bullshitty template matching. What happened here? Compute puff advantage CUDA. Okay. This really should not be that difficult. Presumably there's a bunch of other stuff. Okay. This build is obnoxiously slow now. So something's getting, like... Something's getting messed with. Okay, this runs. Yeah, this runs. Cool. Now this is still 1,700 frickin' lines. But it's 1,700 lines because we're duping everything. Right? At least I'm pretty sure. Let me go look. Not this one. I think it's the stuff down here gets duped. The kernel profiles are fine. It's the high level prof that's redundant. Probably a few hundred lines worth. Create sample logits args. Okay, I forgot we added this kernel as well. Yeah, okay, so what's this? Profile forward call. Yeah, so all the freaking forward functions. This one's super duped. That's what I thought. Why do you think there aren't more people? Because the hype thing is LLMs. They're missing something, of course. They're just focused on their thing. You think they care? They're getting investments, they're getting money, they've got some tech. They're not thinking about getting every possible thing done in science. What's he develop? Oh, that is killing it, Claudes. That's funny. This is very true. Why aren't they dedicating a small team? Because they went all in on the one pretty shiny thing. It's really not that complicated. It's like when I was young, I also thought that every important problem out there had a team of brilliant scientists working on it. That's just not how the world works. profiler shouldn't have frickin' Adam. There. And then this profile kernels file should get down to, I don't know, 1200 lines maybe. I think the hyper setup can get reused as well. Yeah, this thing here. Calls this, which is good. Oops. 1600. This should be shorter. It should have gotten way shorter than this. So we'll see what happened. Yeah, even the core RL people. Cool. This runs now. Why did this not get way shorter? Look for redundant bullshit. Substantially better either way. What the heck is this? Oh, yeah, that's fine. $1,600. Quick commit here. Gotta get some drinks. Okay, so that is actually, oops. Still minus 200 lines. Should now be getting shorter. Should be getting shorter, not longer. For the most part. Tricky, isn't it? Now we'll start getting something rather quick here, I'd imagine, from this. This one function that I have to have is very stupid. That's torch being dumb, though I can't do anything about that. Yeah, I'd like this file to end up being all these graph ops mostly. We can move. What else is in here that doesn't need to be here? We look. Yes, this doesn't need to be here either. Well, annoying that it's also messing with this file, so I can't just edit it now. Okay. All this stuff is fine. So where's the bullshit that I don't want to be here? Okay, actually a lot of it is the models. Yeah, 578 lines worth of models. I don't know why the fuck it put cosine annealing in there. It's just dumb. I'll let it do that. I'll move cosine annealing back in. What's this? Min Groulet. Okay, so it is actually... Most of the redundant crap is, in fact, the models that should just be in their own spot. And then we have a bunch of these forward decks that need to get moved into kernel land. There's also this environment stuff that we need to figure out still. And then the only other thing I see is this clip grad norm, which is, I can't do much about that. This exists because Torch is stupid. So 100 lines of Torch being stupid. The rest of it's pretty reasonable. Way better than before, let me say. I'm surprised I haven't gone through all my tokens as well. I don't know. Not bad for one day refactor. It was very funny when they said, "Oh no, we're not testing." The one thing that's bad about this is that they said, "Oh yeah, we're not testing ads," and then like literally 1 month later they do this. Okay, so this gets moved. This is literally just moving code. That's fine. We're not going to have too many files. I think it's just going to be the policy. Okay, like this stuff, dude, why the fuck is this down here, right? Flip. Yeah, you can go here. Or whatever. And then this one can go... this one actually can go back, I suppose. Because of the way we have it for now. Clip grad norm can stay where it is. I'm getting hungry as well. I think my family kind of planned an early dinner. I might just do that rather than like sit here all day. Long stream been 6 hours. We've made some good progress. Just finish this refactor basic stuff. Good talk. 1K lines. I mean, the rest of this should be very easy for me to just have Claude move around. Yay. Yep. What the heck is wrong now? Really just do not like the way that module's working. C++ 1-bit. Weird namespace crap. Why the heck is that there? Must not have caught that. Should be researched and isn't besides RL. Probably tons of stuff. But the thing is, I don't have a deep knowledge of every branch of science. I can say that based on what I'm doing in RL, I think that a lot of areas of science that heavily leverage simulation are going to see a lot of benefit from this stuff. I don't know like what other areas are just being completely neglected in the exact same way though, right? Like how would I? What do you want to get done for Puffer 4? Oops, did I build this correctly? Well, this whole thing needs to be cleaned up. It needs to work with all of our ends. I need to be happy with the state of the code. I need to be happy that we have good profiling on every possible chunk of the code, pretty much. I need to run quite a few tests on the new architecture to make sure it's as good as I think it is. And then pretty much once I have the whole of the new backend integrated, then I need to do Constellation, which is the experimental chunk of it. We have tons of experiments to launch. And there will be quite a bit of writing and polish as well involved with the release. There we go. That's nice. Yeah, this works. And just have it move this. Use the restroom real quick and go grab one more drink, and then we will finish this chunk off. Yay. Okay, let's finish this last chunk of work. The one thing that I don't have, we don't have CPU fallbacks for literally anything. 1 second. Okay, yeah, we don't have CPU fallbacks for literally anything other than this kernel. I never found a good way to do that, unfortunately. Classes. We can just move this. Change the setup as well. Let's see if this refactor is done. Make sure the profiler works and the main build works. And then this is like, I'm gonna say that the progress from today is we almost have it in a form that like looks similar to something shippable. That's about the level we're at now. Before it was just like colossal mess. Now it's mostly like high level kind of okay, few major things to fix, a lot of minor things to fix, but looks reasonable. I don't really, do I care about CPU fallbacks? I might still care about CPU fallbacks. Sound beat? Yeah. I'm gonna have like a really early dinner and call tonight. I don't think I'm quite sick, but I think I was probably exposed to something and fighting it off. Okay, profiler seems fine. Cosine annealing for reward decay, do pass it. Total time steps in chess. End up duplicating that. Yeah, so that's the annoying thing, right? Is that you don't know the total time steps. And like presumably it's now you have to go across the sub-process barrier as well, which is annoying. Yeah, I don't have a great way other than like special case just adding a function for your thing, right? This is one of the annoying things about multiple languages plus sub-processes plus all this crap. Is very difficult to communicate stuff. Like I'm sure you can hack it, but I don't have a clean way to do it. Okay, we still run. Still train. Yes, that's solid. Okay. It's way better. 1,000-line file. Everything's way more reasonable. Major Batman vibes. I'm feeling great today. I'm cozy Saturday. I figured I'd still stream though. Action route. Yeah, try that, Jess. See if it works. It's gonna be annoying because like it'll change the buffer shapes and stuff. Socket, nah, that's gonna be super slow. We don't use that stuff for RL. I mean, this is like, I'm gonna say decent overall at least. It's way better. We didn't get multiple M's in today. That was maybe a bit too ambitious. Can we get rid of these awful forward decks? Can we get rid of these awful forward decks? Like, yeah, there's still so much mess. Oh, I don't want a frickin' .h. Try this. Included once. Decides to deal with Echo. So weird. Yep. Let's add these guards. Funny echo pattern. So I still don't know how I want to do all the includes for this crap. We're not having headers for everything. That sounds like awful. Oh, piss off. Possibly we can't do from modules. Why is it modules? I'm getting tired for today, so I'm gonna end up having to stop anyways. But yeah, I think there's still some moving around of stuff needed. There aren't actually any CUDA functions here, right? Yeah. We don't have launch functions, right? Then it doesn't need to be in there. It's fine. I think we still need to get into like the whole modules business is like weird. Torch modules. We also have the bfloat 16 stuff to try. Um, we're nowhere near done, unfortunately, but we've made good progress. Okay, so it's not getting double appended, fine. Torch. That's better. Tried to probably hash include the kernel's code. Pound include. And zoomer hash include. Come on. Launch functions needs to go. 4 declarations for the launch functions, really. Oh, god damn it. Fine. We'll figure this thing out later. That's what I didn't want, man. Fine, we'll do this shit for now. We're not keeping that. Oops. Annoying thing. I really, really just hate headers as a concept. I hate the idea of having to duplicate shit in extra time for the sake of it. And then you get programmers where it's literally like a compiler quirk. And they'll say, "Oh no, actually, you need header files. How else will you know what the function signatures are?" I'm not happy with that, but oh come on. Yeah, this should be in here. Bleh. See, like this is where it starts doing awful shit. Again, this file's not going to continue to exist. Oh, this is using torch? Nah, this is stupid. I mean, I'll let it do this, but to see if it works, but I doubt it. Oh no, does it put it in kernel CU? No, undo that. Why would you ever do that? Look how stupid this thing is. You're gonna tell me these models are smart? Fucking hell. Oh, yeah. Okay. I mean, this is why I had This is why I had it included in the first place, right? So they didn't have to deal with this shit. I'm gonna figure this out later. I'm gonna leave this uncommitted for now. Because I gotta get to dinner. But there's a great demonstration of why you don't just let Opus do things. I'm gonna have to figure it out. I'm gonna have to myself think about how I want to structure this so we don't have like horrible include hell. Thank you all for tuning in. I'll be back most likely on Monday. If you're interested in my stuff generally, please feed the Puffer star at puffer.ai. Like, feed this guy a star. He likes stars. Almost a 5K. And follow me on X for more RL content, and you can join Discord to get involved with dev. Goodbye. Enjoy your weekend.